We are.
Can you see the screen, right? Awesome. Are we live streaming already?
Good morning, everyone. Welcome to Ati Motors webinar series. I'm Dr. Rangarajan, VP Strategic Relationship at Ati Motors. We have started this webinar series in the interest of making AMR more aware of customers, aware of the AMRs and their functionalities and features and implementations, how it can be used in I4.0 automation. We have accumulated a great deal of knowledge for last several years deploying our Ati Sherpa brand of AMRs. So we thought that it's up to time to share lots of this accrued knowledge. Our knowledge comes from deploying AMRs in two-wheeler, car industries, bus, truck manufacturer, facilities, tire industries, glass, pharma industries, etc. They are fast embracing the I4.0 automation, and automating the material movement inside their facilities is an inevitable component in their process flow. Ati is the first one to introduce AMRs with the 3D LiDARs, natural navigation, ISO autonomy safety certification. We have proved affordable automation solutions using its Sherpa brand of AMR products is indeed possible with the large-scale implementation. However, these days we have more vendors offering a lot of AMR solutions, so customers have choice to pick up the right type of AMRs for suiting their use cases. So the deployment has become a little more challenging, requiring a new paradigm, and how Ati is offering a solution to solve this, accommodating multi-vendor AMR fleets. Before we jump into the lecture webinar today, little housekeeping notes. All the participants can share their questions on the Q&A window, and we will do our best to group similar questions to minimize redundancy. Today's topic is understanding VDA 50/50 from Ati Motors perspective. The speaker is an industry veteran with immense experience in telecom, IT, cloud computing, and robotics. At Ati Motors, he has been since inception. He has led the efforts on product development management. He has spearheaded the standard compliance, and most importantly, he has defined novel AMR fleet strategies, deployment strategies especially, and it has become practitioner's guide at Ati. Without further ado, please welcome Guru Prasad.
Yes, good morning, everybody, and thank you, Dr. Rangarajan, for that introduction. As Dr. Rangarajan mentioned, we've been deploying AMRs with our customers for over 4 years now. And in the foreground, you can see a diverse set of fleets that we currently have. Before I go into the details of this topic, which promises to be a very interesting one, I will introduce some terminologies which we will be using in the course of the presentation. So for example, when we say AMR, we are talking about autonomous mobile robots, which have an element of natural navigation in them. We also have AGVs on the ground. I mean, these have already been deployed. Although a generation older, they are still in the manufacturing floors. So AGV is an automated guided vehicle, which needs a strip of some sort on the ground, either magnetic or metallic. And it's guided along the strip. So hence it's called a guided vehicle. When we talk about customers, we are usually talking about either a manufacturing facility or a warehousing facility, both of which have needs for serious automation. So they typically end up using either AMRs or a combination of AMRs and AGVs. So a fleet is a collection of such AMRs or AGVs in a facility. So when we talk about an operating area in a facilities, and especially where the AMRs and AGVs work, this could be the specific routes that the customer has deployed the AGV to get a logistic movement done. And so that would be under the aegis of the map, and the specific routes do something useful on the shop floor of manufacturing facility. And when you have multiplicity of AMRs or AGVs, there is usually a software component on the network called the fleet manager, which basically manages the activity of the fleet, coordinates, and gets the best done out of the fleet. Now let's go back to the first slide and take a use case. So for example, what we routinely see on the shop floor is material is delivered to a production line. These come from racks. Customers typically may use a tugging solution using the bot on the extreme left where my cursor is. This typically has a trolley attached to it, and the raw materials are taken from the racks to the production line. And when the production process is complete, the finished good may still be in a trolley, and it's then taken to perhaps a QA station or a certification station, where after due processing and it is certified by QA, they are then boxed, and then the boxes are placed and a cube is formed. And then you quickly see that the tugger is no longer useful. And instead, you would need something like this, which would then carry the pallet on which the cube of boxes are placed to the finished goods section. So in this use case itself, you can see a multiplicity of AMRs used to solve a particular problem. And as Dr. Rengs earlier pointed out, although ATI has a fleet like this, customers have a choice. They may end up choosing tuggers from one vendor, and maybe the pallet mover can come from another. The situation is such that you have multiplicity of fleets, multiplicity of vendors, and multiplicity of fleet managers which are managing their fleet of bots. And this picture sort of summarizes that. So each vendor has an operating area, that is their map, and there are routes there. You pick and choose robots because the use case needs it specifically. And then you end up with islands of computing like this. There isn't much of information exchange between these elements. Each comes with its own fleet manager. FM is the fleet manager here. So to do a use case like an orchestrated use case, like you start with material movement and then automatically hand it off to movement of the finished goods to the endpoint, requires orchestration across each of these. And it's extremely difficult to do if you do not have a single orchestrating entity. Often we resort to different ways of signaling across fleets to sort of achieve that objective. But when you look at it from a customer point of view, the operator of the customer now has to look at 3 different dashboards. So let us say he wants to order material movement from the racks to the production line. He would end up using the dashboard of this fleet manager. And yet when the QA is done and this has to be now shipped to the FG area, the finished goods area, he would then resort to another interface, making the life of an operator there and the ramp up curve to study and master multiple interfaces is a little too much. And from a customer's point of view, especially from a cost point of view, customer has paid for 3 different licenses when most of them are doing very similar things, which is assigning bots to AMRs to do logistic operations, to do traffic management, so on. Each one of these are doing something very similar. And it begs the question, why cannot we have a single fleet manager which sort of does all of these? And from a customer point of view, they don't have to buy 3 licenses from each vendor. And also, the number of, from an engineering point of view, you have two less, at least in this picture, let's say there is only one fleet manager. So you have 2 less entities, both hardware and software, and less entities to manage from an end-to-end engineering point of view as well. So also, such multi-vendor fleet management is typically complex, and it is not the expectation that customers solve the orchestration problem. It's up to us as manufacturers of AMRs and fleet managers to be able to do the right thing from a customer point of view and not expect that they mediate across these vendors to get their job done. So one thing I didn't mention is doing traffic management when 3 elements of computing are like this is very difficult. And what I mean by traffic management is the vendors, so the vendor AMRs could cross intersections where they both approach an intersection and move on. If we do not meter such intersections, it could easily lead to deadlock. So the key takeaway is multi-vendor fleets are a reality today. And there is a need to have a single orchestration fleet manager, which enables common communication across elements of the fleet. So that is the background with which we are trying to understand what VDA 5050 can do to solve the problems that we have today. So the VDA 5050 standardizes the communication between the fleet management system and AMRs or AGVs that are elements of the fleet. The spec is in version 3 now. It's actually published by the German automotive industry. So not only does it standardize communication, if the 2 ends of the pipe are speaking the same language, an AMR between vendors, they could talk to a single fleet manager, so thus enabling interoperability. So not only does it solve a technical problem in that AMRs and fleet managers, diverse set of those can talk to each other, but also reduces the number of components in the system. And so when we talk about VDA FM, we are typically talking about a fleet manager that not only aligns with the standard and employs standardized communication as defined in the spec for all the interaction between AMRs and AGVs. A quick summary of the problem and what the VDA 5050 does to solve it.
Let me just take a pause and then try to understand. You've covered quite a set of data. One thing is that multi-vendor fleets are common, available, so customer has a choice that suits their use case. The second thing is reduction in cost when they choose appropriate thing. That is definitely customers' prerogative to choose the right one that optimizes their either operational efficiency or the reduction in cost, etc. The third you mentioned about the traffic management becomes a lot more easier. If you go to the previous slide, you mentioned that the customers are not definitely subject matter experts. That's correct. And it's outside of their scope to mediate with vendors. That means whoever is going to provide the VDA 5050 should discuss, converse, and make other vendors listen. I mean, they are offering the VDA 5050 equivalent or the same protocol available on their fleet. How does it initial conversation begin?
Yeah, so the right thing to do at this point is to see if vendors have standards compliant fleet managers, and the VDA 5050 is one of them. When you enable components which are standards compliant or enable or deploy them in your network, interactions between them. So for example, the elements of the fleet can now talk to any vendor FM and vice versa. So the fleet manager can really talk to multiple entities on the shop floor. So this would help the customer orchestrate the manufacturing process a lot better. And as you mentioned, with Industry 4.0 and touch-free automation being the next goal that most people are striving for, it's important to have islands of computing that also talk to each other rather than have work in different silos of their own.
Thanks, Prasad. Do you have one unified way of showing that how the VDA 5050 from Ati Fleet Manager perspective? Can you take us?
Yeah, absolutely. Yeah. So that so this is the common architecture that the VDA 5050 helps us achieve. So in this case, the fleets do remain as they are, but they are speaking to a single master fleet manager. We have, of course, built it, so I've named it Ati Fleet Manager here. But most importantly, that it is VDA 5050 compliant. So the messages that go between the master FM and elements of the fleet are governed by the spec. That is the VDA 5050 specification, which says messages payloads have to be in JSON and a certain structure. This is a little bit of a technical term here. Please understand it as a structured message that goes back and forth. So with this model where the elements of the fleet are talking to a single master fleet manager, and both ends of the pipes speak the same language, it's possible to visualize a single dashboard, such as what you see on the top of the screen here, which we call as Ati's unified real-time dashboard for multi-vendor fleets. So what you see on the screen is a near real-time positioning of bots in the space from multiple vendors. So for example, you see Ati's bot as well as other vendors, AMRs or bots, as I'm using the term interchangeably. So they can be shown on the screen. And what's more, we also provide a single canvas on which the operator can do logistic movement. So let's say the operator now wants to order a raw material movement from the racks to the production lines. He would use the same interface which is available on the dashboard to do something else also. For example, he would, if he or she wants to now move finished goods to the FG area, the interface remains the same, and it's easy to master, and there's only one. The learning curve is less. The cognitive load on the operator is vastly minimized. So those are some of the benefits. Now there are structured messages for each of the activities that goes on. For example, if you book an order to go from A to B on the dashboard, a certain JSON message gets sent from the master fleet manager to that specific fleet. You could also do instant actions. For example, you want the AMR to stop for some reason, or at the end point trigger the activity of something that it is carrying. For example, here you can see a pick and place element on top of the AMR. Now, when this AMR goes to the endpoint, you could use something like the instant action directive to get the PNP to work in synchrony with the movement, so that so the larger goal of end-to-end automation, touch-free automation is that process is realized. There's also AMRs that need to be sent to a charging location, and the state message that comes back from the AMRs to the master fleet manager also has battery information. So it enables the customer to set a top level directive which says if the state of charge of the battery is below a certain threshold, the expectation is that the master fleet manager would immediately direct the AMR to the charging station. And certain AMRs may even require a message to be sent to start the charging process. So all of these are possible as per the standard that is defined in the VDA 5050. There are multitude of benefits to the operators. I went through some of them already: uniformity in visualization, uniformity in operation, and reduced cost.
Prasad, I think this is a kind of a dense slide. So MQTT is the bridge, and Ati or any other vendor fleet talk that language supported by MQTT platform. So as far as the master FM is concerned, all these AMRs will be treated as first-class objects, right? No distinction
Absolutely,
between.
yeah. Yeah,
Um,
all the fleet elements are treated as first-class citizens, yes.
okay, so that means your specific JSON, orders management, localization update or incident, they will be sent to particular AMR or particular fleet, or but only message is the most important thing. For example, instant action, we can take it. Suppose some emergency shutdown to happen.
Right.
Will it be sent to all fleet or to a particular thing, or how does it at 10 points when you say there are instructions can be given, but instant action is how does it work? I mean, the language FM.
Okay, yeah. So the message passing gateway is an MQTT bridge. The standard, the VDA 5050 standards says that use the MQTT bridge, but what we need to take away is the MQTT bridge is basically a messaging platform which facilitates the movement of messages from multiple vendor fleets to the master FM. So the uniform messages that go back and forth are going via the bridge, and this is an essential component that needs to be deployed as part of the master fleet manager. This is just a communication platform at this point, and nothing very specific about VDA 5050 in the way the MQTT itself is implemented, because it's a generic messaging platform used in multiple enterprise solutions and so on. Back to the question on how do you use instant action to sort of bring a complete fleet to stop. So when elements of the fleet are powered up, they would then connect to the master FM. So you would know at any instant how many elements are actually connected. And you could have top level directives on the dashboard, which can call to action would be the call to action could be to stop the entire fleet. So the one way of implementing that is to send an instant action message to each one of these bots, calling them to stop. So that's one way of making sure the bots stop. But the instant action is used for multiple purposes. The other example I gave was this one, which has a pick and place arm on top of it. The instant action let's say this is going from station A to B. And when it is at B, you would then want to trigger this arm to pick and place a particular payload that is on a table back onto itself. So you could send an instant action to get this to move, for instance. So a variety of use cases are enabled by the instant action capability. And of course, stopping them is one of them, but you could use it to do some other things as well.
On the orders management, the work order, when it is sent to an AMR, it's based on the stations or the nomenclature that needs to all have to agree on all multi-vendors when they are crossing, etc. That would be a challenging thing. Or if it's going to come later, that's fine. I just thought that I'll go one at a time. We can go to orders a little later, but the charging directive, some can be swappable, some can be directly docking. Those are special instructions to be given to the AMRs, or all have to be baked into the.
Right. So for example, Ati's fleet of AMRs are swapping types. So the top level directive when the SOC runs below a threshold is to simply ask them to go to the charging station, whereupon the battery can get swapped. There are yet other types of AMRs and AGVs where you would then have to ask them to do last mile operations, like let us say they can plug themselves into a socket and so on. You would then activate via instant action, for instance, to be able to activate the charging process. And that is a completely automated charging process. It actually depends on what is the AMR and what are its capabilities when you talk about charging and other things. But let's go back to the order message that gets sent. So each of these fleets are doing something useful. So for example, there are stations from which you start the material movement. So they would have naming conventions that make sense to the operator in question. So the metadata that gets visualized here in terms of what is station and where do you want the material movement to happen, say for example A to B, would then show up on the screens of this unified dashboard. So the operator can choose that the material movement can happen from A to B or C to D and so on. So that metadata is part of the map meta information that comes from each of the fleets. We'll talk a little bit more about how maps are created and stored a little bit later. But yes, it's an important aspect of order management.
Before we go further, there is a question from our participant. I'll read out the question. Is VDA 50/50 communication between AMR, any brand, to fleet or fleet to fleet? When you say data through MQTT, is data flow from AMR to other connected fleet or two different brands of fleet?
Okay, it's an excellent question. So the VDA 50/50 is basically a specification of the message flow between AMRs and the fleet manager. There is no communication between AMRs outside of their fleet, and in fact, even between elements of the same fleet. So the spec only talks about how you would interact with the master and also how the master can send directives back to elements of the fleet. There is no communication directly between the AMRs of different fleets, nor is there communication between elements of the fleet themselves. They could have this for reasons specific to an AMR vendor, but that is not part of the specification.
So in short, it is not a peer-to-peer communication protocol.
Yeah, but they may have it for other reasons, but it's not a purview of the spec. Yes.
Okay. Please go ahead.
Yeah, I hope I answered the question. There was one mention of MQTT, so that's basically a messaging platform. So it just helps publish, subscribe kind of models for sending messages back and forth from the master to the fleet elements. And to reiterate once again, there is no direct communication between AMRs of any fleet.
Yeah, there are a couple of other questions on the map and Wi-Fi, etc. I will listen to further and then sum them up to them.
Okay, so now that we have implemented the fleet manager, the RT fleet manager compliant with the VDA 50/50, I would like to talk a little bit about the challenges we faced and how typically these challenges are overcome. But before that, I want to talk a little bit about the deployment models that this enables. So that the first slide is the standard model that you saw already. So there are two fleets, both talk to a master fleet manager in a VDA compliant messaging way. So there's nothing very special about it. This is what the spec says. But the spec also allows an alternate model where you can go through an aggregator fleet manager on the left side where my cursor is. This fleet is talking directly to the master. But a vendor fleet can actually have an aggregator sitting in between, and the master FM talks to the aggregator. This language is VDA 50/50. However, the aggregator FM can talk to the vendor fleet in its own private protocol and so on. Then it's the responsibility of the aggregator FM to present a facade such that from the perspective of the master, it looks like it is talking directly to elements of the fleet. Yes, both these architectures are possible. This is one that is more widespread, but this is also possible. Now,
is one preferred over the other, or is it?
I don't think it is preferred, or both the models are possible. This is the more popular one, I would say, but it is also possible that there is a lot of other information that aggregator FM and vendor fleets manage, but they still want to work with a compliant master. So this may be equally popular, I would say, at this point. So there is no preference for one architecture or the other, but straight away when you see the architecture, you would kind of visualize it with this model.
Although in the other one, the message will be just passed through the aggregator FM. Will it introduce any latency lag or nothing to bother about the implementation? I mean the effect or takt time, etc. When we
have it is a good question. So I can only talk about network latency, typically all of these are deployed on the same customer Wi-Fi in most cases. So I cannot talk about the way this has been implemented, but from a network perspective, since they're all on the same Wi-Fi, the overhead of a one hop step before you actually reach the MR could introduce maybe like a 25 or a 50 millisecond overhead. But inside the box, as to how it has been implemented, depends on the vendors. So there may be some computational overhead that this box can introduce, but hopefully that is a minimum. But from a network point of view, there isn't going to be too much because they're all on the same Wi-Fi. I hope I answered that question.
Thanks, Prasad. Sure.
Any other question on that? Okay, I'll
No.
just go into the complexities of the implementation, what we had to do. This is actually quite a common question that we get. Are you going to force a common map? The answer is no. Here you can see that the dark gray background here is the entire shop floor. So in that you can see 3 different fleets operating, and so each one has its own notion of a map, and inside the map there could be potentially multiple routes that each of these AMRs are executing. And in this particular case where there are 2 fleets, it is also possible the routes of these 2 fleets can intersect. So all of their maps have their own reference 00 as I'm putting it here. This is a vastly simplified diagram where I've shown the maps to be axis aligned. Otherwise, you would also have a rotational theta component here, which I have not shown. So now, when these bots send location updates back to the master fleet manager through the VDA 5050, the X and Y location of the bot comes with a reference to its own map 00. So it's also possible to see how these are placed in the context of the larger plant layout. So for example, this is the plant reference. And you can quickly see that if I get an update from this bot saying it is at 1010, I can quickly say add the XT and YT and position it in the larger context of the map. So this is how the visualization is done. And maybe even there is a rotational component. All those can be applied as simple transformations, and the bot can be visualized in the context of the larger map, which makes it easy for the plant operator because they want to see references that they are comfortable with. So this larger plant layout would then have a lot of detail that I'm not showing here. These are specific things on the shop floor that they can relate to and know exactly where the bot is when it is visualized. Once again, there is no attempt to create a common map. The location information can be transformed and shown in a meaningful way to the operator. Is there any question on this, Dr. Rains?
I do see a universal frame being used for the transformation.
Right.
Between actions to be taken on either fleet 1 or 2 or any fleet with respect to the origin 00 of the universal frame. Right. I think we applied every time an action to be taken or a location update comes from that fleet, it would be with respect to its frame, but when we display it on the common dashboard, probably transformation would be applied and shown.
Yes, and this is an extreme example where you have all the fleets here and maybe 2 of them are intersecting, and so the at least this part must be shown on the same frame simply because these may intersect. Now it's possible to visualize this fleet in a completely different tab, saying I want to switch to this fleet and look at this fleet in itself because there is no other interaction. But people who are operating these 2 fleets would rather see a combined view where both of these are visualized so that you know where the bots are, and especially because they have a common area where both of them are operating. Yes, so for those you would apply a transformation and show it in a way like this, but this can be visualized with just its own reference coordinates and doesn't have to be transformed to plant coordinates. I hope I answered your question.
That's cool because wherever there is intersection, they want to see.
Yeah.
I mean, the idea is that VDA 5050 will also protocol will make sure deadlock is avoided and things like that as traffic management is taken care of by the master FM itself. But
Right.
none of the visualization is very important for the shop floor operators, so that in case of any other things leading to issues, they should be able to resolve it quickly. So the common view is, display is very important. That I get it. Another thing, we don't attempt to create a common map. That's what you say. But is there an interchange format for layouts? Any attempt has been made in that? Any layout interchange format or something like that to answer this kind of questions, or it's too early to
There is no specific map standard. I must add at this point that each of these maps have been built with a sensor suite that is unique to the bot itself. So, for example, this AMR bot can have multiple cameras as its both as its mapping and primary navigating sensor. Ati's fleet, of course, has a lidar and a camera. However, the output map is not loaded with any sensor data because it's only showing the location of key elements of the map relative to. However, when they are navigating, it's important that their map be the guiding map that they use to navigate would be something very specific to them, and especially because there isn't any known map standard that we see coming up. So they are left to use their own map while they are navigating. However, when they are being visualized on the screen, a common frame of reference could be used to show them.
Sure.
It largely depends on what is the sensor that you're using, how dense your map is, because that dense map is what enables that bot to particularly navigate in a special way and so on. So that, we don't want to change any of that.
But I obviously believe that there will be a distinction between fleet from vendor one and fleet, some kind of these are widgets and color coded things to be done, nothing specific to protocol itself, so that operators are enabled to take actions quickly, right?
Right. So these would be shown a certain way. Their routes can be color coded. So you know specifically what are the routes that each fleet operates. They can be color coded differently so that the operators can see and understand what each of these fleets are doing and so on. And especially when there is an alarm, an alert, or an alert from any of the elements of the fleet, you would be able to see it on a unified dashboard and take the right kind of action or recourse to fix it.
Yeah, please go ahead.
All right. Yeah. So this is usually an issue that most AMR vendors worry about, but they are left to use their own maps. There is no attempt to create a common map, and is also important thing from a customer point of view that we are not going to change anything, and these AMRs are already working on the shop floor in a certain way. So let's talk a little bit about one other complexity here. Sorry, yeah. So this is also a common question that we get asked. So now that we have VDA 50/50, so how exactly is intersection management done?
Prasad, exactly, there is a question related to this. I'll read out so that with this architecture, how traffic conflicts and priority management, since two different fleet already assigned mission critical, the mission, and safety will stop the AMR when they come across. So I think this is a scenario the question says. I think it's the right time that we have an answer for this question.
Right. So there's a couple of ways we can do traffic management. I will highlight one and also talk about the other one. So here's an example of a situation that needs traffic management. We have an AMR going from A to B, and there's also an AMR going from C to D, and obviously from two different vendors that particularly shown it that way. So one of the things that the VDA 50/50 helps us do is to show subsegments as the start and end points for the operation. So for example, if we take this AMR going from A to B, we could potentially break up that segment to be a subsegment from A to I and then another from I to B. And with the map metadata that gets uploaded, we already know that this two routes would intersect, and that we would need careful consideration when bots are navigating through the intersection. So one way is to let this AMR go only from A to I. It it is not aware that it has to go the second segment I to B upfront. Although the operator decided that they requested that the bot go from I to B, A to B, what is shown to the AMR is only the first segment A to I. And why is this done? Because we know that there is a intersection here. And similarly with the bot that's trying to go from C to D, since they intersect, only this segment is shown to the bot. So it could then, both of these, if they arrive at the same time, whoever came first would be given the second segment directive, which is, let's say this bot came first. So after reaching I, it would send a message saying that I have reached I. And we then don't let this bot know anything about the segment I to B, and instead let this bot go from I to D. And when it has safely crossed, the master FM knows exactly where each AMR is. And when it has safely crossed, it's the second segment for this AMR, which is the I to B, is disclosed. And so it makes its way through the intersection quite safely. So let's say there is another one coming behind it that would obviously be held up again here. So this makes a safe passage. And this is one of the ways of ensuring traffic management and avoiding potential deadlocks. There are also other ways that we can do. I mean, we can add to the MQTT protocol to add parameters. So we have a REST API that can also be wrapped up around an MQTT message. The REST API is for vendors who know that they're approaching an intersection. So let's say the AMR vendor of this knows that it is approaching an intersection. It can talk to the master FM using a REST API. And then once it is given a permission to continue, it would then enter the intersection and clear it. This is over and above the VDA 5050 protocol. That is what Athi has chosen to implement. I just wanted to highlight that these APIs are available for all vendors to be able to do intersection management in maybe a slightly different way as well.
So let me get this clear. So VDA 5050 does not specify how to do the traffic management. It is up to the implementer to take care of that, resolve the issues.
Yeah, it doesn't specify a whole lot about how this needs to be done, although certain obvious things are there. And since you can send segments of enablement to the bot, you would potentially do traffic management in that way. So really you would be sending an order go from A to B because that is what the operator wanted to do. But being cognizant of the fact that there is an intersection, a lot of heavy lifting is done by the fleet manager to be able to do that. We also, as I mentioned, there's REST APIs and we could do it another way as well.
So all this what to be done in preparation to make sure that traffic deadlock doesn't happen.
Right. There's a lot of paper and pencil exercise and careful capture of metadata. Some of this can obviously be deciphered from the metadata uploaded, that these are potentially intersecting here. But it is also possible to use a system and upload data saying that these are,
There could be multiple intersection. Doing it
yes.
One by one would be, is there a tool chain or something that Athi has?
Yes.
I mean, so coming later, that's okay. I just want.
Yeah, it's an important question to be able to do these kinds of things successfully and quickly and iteratively, because when the deployment, when bots go into deployment, production ready deployment state, there's usually several weeks of hard work that has gone in to make sure they work in the most optimal way, in the best possible way for customer operators, the positioning, where it turns, where it stops, all of those are finalized. When you do this in a very iterative fashion, you would want to have a tool chain that supports the operator, and we'll talk about that in a little bit. There is one slide on that, but I would want to finish off the challenges here. This is one of them. Here is a more, this is a little too technical, but nevertheless needs to be mentioned at least. So the challenge that we foresee is that you are now working with differently abled AMRs. So for example, some of them are AGVs, and what I mean by differently abled is the kind of path planning that they do. So let's take an example of something going from A to B. So AMRs, a top level directive that it should go from A to B is enough for AMRs, because typically AMRs have, typically there may be exceptions. They do the computation to figure out how to go from A to B on board. So you don't really have to say, hey, by the way, go through points in these sub-points. This could be very dense set of points. I've shown it in a scattered way here. This computation to decide what is the specific route that it would take can sometimes be done on board the AMR. Whereas AGVs typically don't do that, and they expect that the master says exactly what are the sub steps, the P1, P2, P3, that the intermediate points in the route from A to B, is part of, they expect, the AGVs expect that this be part of the trajectory segment of the order message. So yes, these are things that you should consider as a master vendor implementer, which is what we did recently. To be cognizant of differently abled AMRs and AGVs in the fleets that we are trying to manage. So this level of detail requires working with AMR vendors and both parties to arrive at a consensus as to what is the level of detail you want from the master effect. This is a common topic also, because if the AGV is not given these points, it can do precious little. It expects that you give the intermediate points as well. So this is a detail of path planning. We don't have to get in, but at this point, what you need to take away is there are differently abled AMRs, and managing their routes and navigations is a challenging exercise.
So this will come very useful when we go, wherever the master FM has to be, go for a brownfield implementation where AGVs are already present and intersections are going to be there within current or new AMRs. This particular computing of the substeps P1 to P4, etc., to be should be accounted for on the master.
Absolutely. Then so they expect that the master take ownership for this level of detail. So some heavy lifting has to be done by the master firm.
Okay. So a little more in terms of so that actually asks the question whether it's a low code, no code kind of implementation or configuration based.
Okay. It's a good question, Doctor. So let's see if we can do justice to that. I wanted to see if I covered all the challenges. We talked about multiple maps, and each one has a map of its own, a lot of metadata that comes in. Then we talked about the intersection management, how potentially there are a couple of ways. If AMR vendors can call the REST API, it leads to perhaps a simpler implementation of traffic management. We talked about path planning and differently abled robots to be managed. Okay, so that leads us to an overall deployment slide. These are typical elements of when you really see a practical deployment of a robot fleet, multiple fleets thereof, you would end up seeing something like this. So when, as I mentioned earlier, by the time you get a robot into production mode, several weeks of hard work has happened to make sure that it meets the expectation in a perfect way. So each solution is unique, each customer's requirement is unique. So when you go through the motions of doing the right thing from a customer point of view, you're going to be changing the routes often. You're going to change the names of stations. You would also discover there is a lot of intersection that's going on. So these kind of metadata, you would expect that there is a easy way to upload this data. So why is it important to upload metadata, map and metadata? It's because the map and metadata can get sent to each of the elements of the fleet. So one way to do that is to have a low-code integration possibility where the metadata is called out in the deployment manager, where you actually enter this kind of data. And there is a quick integration between the master and the deployment manager. Makes it easier and less onerous a burden on people who are actually trying to make this work on the field. So this is what Aki is working much more closely. We do have a deployment manager. We are trying to make it ever so easy for the operators on the shop floor and as well as our own service teams, which actually deploy these fleets, to be, to ease the burden on them and trying to make all of this thing work. So the other requirement more from a customer point of view is the two boxes here. Quite often customers want the master to be integrated with a common identity server. So for example, we want to track the activities of logistic movement requests done by specific operators during a shift, for instance, let us say. So, and say there's one of the operators is Prasad at Bosch, and they would log in using credentials of their company, for instance. So that would be validated against the customer's identity server. So, and then whatever operation is done by that operator gets logged in an auditable manner. This is a very fundamental requirement. Why did we move this material and who moved this material and when is a question that needs to be answered. So this information is done in a way that the identity of the person is not at all in question because they have logged in using their corporate credentials, for instance. So this integration is something that API Fleet Manager already has, and it is deployed in this way for many a deployment. This is a standard component for us. Many of API's customers also have integrations with their backend, primarily from an Industry 4.0 perspective. So, for example, what can happen in the case of some of the customers that we have worked together is that the recipe and the planning of what needs to be manufactured is already known, and that plan for the next 8 hours is generated by a manufacturing automation system backend. And that plan is uploaded onto the server. And for the next 8 hours or whatever is the shift duration, the master FM simply executes the plan that would have a lot of logistic movements like this: move this raw material from A to B and do it for the next 8 hours and evacuate finished goods from one station, take it to the FD and so on. So, and maybe even coordination between those multiple robots and so on will happen because of directives that are originating from a manufacturing automation systems, essentially called the I4.0 kind of integrations. So we have done these kind of integrations. These Fleet Manager is already capable of doing these kinds of things. I just wanted to highlight that it is not just a box and a VDA 50/50 compliance. You also need to work with several entities to make for a successful deployment. And now we also have the case where we work with multiple vendors. So we want to be able to export fleet-specific analytics in a secure way to the partners who are part of this endeavor. Some of these vendors deserves to get the right data as to what happened to their fleet from an analytics point of view. So these are some conduits that need to be built and makes for a complete deployment. I hope I answered your low-code question. It's we want to minimize.
I think you answered a lot more, so I need to parse one by one.
Okay.
So what you say is that API Master FM has ability to do a single sign-on interface connection for auditory purposes.
Right.
Okay. And then we can also connect to the backend to automate I4.0 kind of activities. But that may require detailed discussion. But unlike SSO can be much simpler than this one, because
yes, absolutely. Yeah.
The PPC can be much, production planning control can be much involved and detailed, whereas SSO would be a easier one. The third one you mentioned about is that involves, because this is a other vendors' data, so it involves data privacy also. How does it? How do we? ATI, gives a guarantee of the data privacy for those data is only shared to the respective customers. The other vendors. It doesn't cross over.
Right. So in the Master Fleet Manager, we have options that can be enabled to not only is the data at rest stored in an encrypted form, data that is going back and forth can also be encrypted for additional safety purposes. And especially when it is exported to another system, we can use secure interfaces to do so. We can also put this data on secure components on the vendor's side. So I just wanted to assure that we have ability to encrypt the data even at rest. So for example, there may be some ongoing trips whose data is available with the master, and this can also be encrypted on a need basis.
Thanks. Couple of questions have come. I'll combine them.
Yes, please.
It's about during the exceptions and errors. When Wi-Fi connection is lost by an AMR for whatever reason, how does that behavior? Each vendor may have each vehicle can be from a different vendor behave, and how does recovery happen? Is there any VDA 5050 protocol? Anything, does it say anything about it, or?
Right. So one of the requirements when you deploy AMRs and AGVs is that you have Wi-Fi connectivity in all the operating areas of the fleet. Now, this is a fundamental requirement. Most AMRs and AGVs of today communicate over local Wi-Fi, although there may be exceptions. So it is important to make sure for more than one reason. I mean, you may have intersections where you're going to have to talk to a master to obtain permission to cross the intersection. So let's go back to the previous slide. So let's say, this AMR is going from A to B, it has now gone up to I, and unless it is connected to the master, it doesn't know what to do next. Even if it uses the REST API, it has to communicate to the master, and if the Wi-Fi is down, it would mean that this AMR would wait at this point for a significantly long time until somebody rescues it, for instance. So the other question was about showing error messages on the screen. Now, let's say the AMR continues to be connected and it's not the Wi-Fi that is the issue. So any messages from the AMR is made visible on the unified dashboard. The call to action may be AMR specific, but at least it is shown on the screen as to what is the last known position, because the location updates are coming at a rate typically once in 2 seconds. So you know exactly where the AMR is in its route from C to D, for instance. So you can look at the message and also find out where the AMR is, and the call to action may be, as I said, very specific to the AMR. There is no particular mention in the spec as to how they should recover, but they tend to be AMR specific. Sometimes just a reboot may work, and so on. But the state message will say I'm in trouble. That's the message going from the AMR to the master FM, and that information can be shown on the real-time dashboard. I hope I answered the question. Yeah.
Thanks for that. No, that's fine. I just want to know about how the exception handling happens. One last question in the interest of, there are a few other questions, but I will make this. Does Sati have implemented VDA 5050, this one, in any of its customer side, and is it ready for deployable at other places if needed?
Yes, the implementation is available today. And as we speak, we have an ongoing integration with one of the vendors for a large automotive manufacturer in Chennai. That is work in progress. We should be concluding that real soon. But I want to reiterate that this release is available, and potentially vendors can start integrating with it.
I think that completes the question answer session. If you want to summarize, we are just running short of time. In about a few minutes, we'll be closing. So,
right. So thank you very much for all the questions. They were made for an interesting conversation. But I also want to reiterate some of the benefits that we saw earlier. So from an industry perspective, the spec addresses an important need from a seamless operation and scaling perspective. From a customer perspective, of course, reduced cost. From an engineering perspective, a number of components are less. So the customers don't have to feel that they're locked in because they've bought AMR and a fleet management from a certain vendor, and so they're obliged to choose other types of AMRs from the same vendor. So there is no lock-in. This specification fundamentally removes that as a potential issue. From an AMR vendor perspective, aligning with the specs creates a level playing field for us. We could, of course, work with our own fleet manager, but potentially we could also work with other fleet managers that are already deployed. So aligning with the specs actually opens up more opportunities than otherwise. So we at Athi believe that the spec is in the right direction, and the spec is also evolving to meet industry expectation, and we are proud to be part of this effort. So thank you all for joining this webinar. If there are any other questions, Dr. Venks would be wrapping up soon.
Thanks. There are a couple of questions come, but I think I will we will take them up and then send messages or update them on the recorded ones. I think it's a wonderful session. a top level view, a little bit of technical, but summarization and QA made this an hour-long session, I think, more productive to all our participants, viewers, and potentially end users. Thank you once again. We would like to have, we will be having similar, more periodic webinars on other topics, and we will keep you updated. Looking forward to see you again. Thank you.
Thank you all for joining. Thanks for your time.